determining the location of a terminal point given the signs of a trigonometric values. So you're going to determine what quadrant the angle theta is in, given what, like in this example, it's going to say cotangent of theta is greater than 0, that means it's positive, and cosine of theta is less than 0, which means it's negative. So let's look at a couple things. First of all, you need to know what the quadrants are. So over here in this positive x values, positive y values, that's quadrant 1. And then we move in a counterclockwise direction. And this is quadrant 2, and then quadrant 3, and quadrant 4. So what you want to remember is that in quadrant 1, your x and your y values are positive. In quadrant 2, we'd be moving in a negative direction for x's and positive for y's. Quadrant 3, that would be negative x and a negative y. And quadrant 4, we would have positive x and a negative y. So you can see I kind of have this little picture here. R is the distance out to our point in the quadrant, and it is always positive. But your x and your y values will be, basically it's considered positional, so if it's a negative, then we're moving in the negative direction. Okay? So here in quadrant 3, you can see I have a little sketched, I've sketched a little picture. Here's a point. R is the distance out to that point. It's your radius here, and your x value would be negative and your y value would be negative because you're moving to the left and then down. Okay, so the other things you need to remember is that the cosine of theta is x over r. Okay, so r is always positive, so when I think cosine, I think x. Okay, so if x's are positive, then I'm looking at something in quadrant 1 or something in quadrant 2 where my x's would be positive. Okay, so sine of theta is y over r. Again, r is always positive, so I'm looking at y. So I associate sine with y. And so, you know, you want to think about when y's are positive in quadrant 1 and quadrant 2. Okay, and tangent of theta is y over x. Okay, so y and x could be positive or negative. Okay, so you want to think if tangent of theta is positive, that means y over x is positive, which means both of them are positive or both of them are negative. So both positives would be quadrant 1, both negatives would be quadrant 3. Okay, now once you remember those, then if you remember what a reciprocal goes to which of these trig identities, okay, these trig values, then it's easy to remember. Now I remember secant is the reciprocal of cosine, because I remember the reciprocal does not start with a c. Cosine starts with c. Its reciprocal does not. So that's secant of theta. So when I think secant of theta, I remember it goes with cosine. Cosine goes with x. Okay? So I follow the same rules. If x is positive, it's in quadrant 1 or 4. If it's negative, it's in quadrant 2 or quadrant 3. So sine's reciprocal is cosecant. It doesn't start with an S, so it's got to start with a C. And I always know cotangent goes with tangent. They kind of go together, those names do. So it's got to be cosecant. So cosecant is the reciprocal of sine. Sine goes with y. So when I'm thinking of cosecant, I'm thinking of my y values. So when y's are negative, that's quadrant 3 and quadrant 4. Okay? So cotangent's very similar to tangent. If my cotangent is negative, that means one of these is positive and one's negative. So that's going to be quadrant 2 or quadrant 4, right? Quadrant 2 I have a negative x, positive y. Quadrant 4 I have positive x's but negative y's. Okay? Okay, so let's look at a problem, and I'm going to refer to a lot of this information. You need to become really comfortable with this information. Okay, so when I asked you to determine what quadrant it is, determine the quadrant in which the terminal side of theta lies, I need to consider both of these values. So cotangent of theta is greater than 0. That means cotangent is positive. So remember, cotangent is the reciprocal of tangent. Tangent's y over x. like slope. So cotangent is x over y. So in order for it to be positive, then I've either got to have a positive value divided by a positive value or a negative value divided by a negative value. Okay? So think of your quadrants. Positive and positive, that's quadrant 1. Negative and a negative, that's quadrant 3. Okay? So that's the cotangent part. And then I need to consider the cosine part. So cosine of theta is less than 0, that means it's negative. Cosine goes with x. So again, think of your xy axis. When x is negative, that means I'm moving in the negative direction. Then my y could be positive or it could be negative. So we're talking about quadrants 2 and 3. So I'm going to put that here. So I can see in this case, it's got to be quadrant 3 because quadrant 3 meets both conditions. Okay, so part A is quadrant 3. Part B. Sine of theta is less than 0. So sine of theta that means sine is negative. Sine goes with y. So when are your y values negative? So again, think of your xy axis. Y's are negative. That means we're moving down in the y direction. So I might have an angle in quadrant. So my point could be in one of these quadrants, which is quadrant 3 and quadrant 4. Okay, so that's for sine of theta is less than 0. Now what about if secant of theta is less than 0? So secant is the reciprocal of cosine. So this goes with your x value. So when is your x value negative? That's what we're looking at. Okay, so we think of our little xy axis here. X values are negative in quadrant. So I could have my point here because I could have a negative x and y could be positive, a negative x and a negative y. Something here or something here. So quadrant 2 or quadrant 3. And so we see quadrant 3 is part of both of these. So my answer for part B is quadrant 3. All right, let's look at a couple more examples. So cosine of theta is greater than 0. That means x is positive. X is positive in quadrant 1 or quadrant 4. Okay, so we're talking about 1 or 4. And then cosecant of theta is greater than 0, so that's positive. Cosecant is the reciprocal of sine. And so this goes with y, so y is positive. Y is positive so that's y is going up, so x could have been positive or x could have been negative. That's quadrant 1 or 2. So we see what's the same here, and that's quadrant 1 for part A. Okay, so let's look for part B. Sine of theta is greater than 0. So that goes with y, so y is positive. Y's are positive above the x-axis, so that's going to be quadrant 1 or quadrant, we have a point in quadrant 1 or a point in quadrant 2. Okay, and then the next part was cosecant of theta. Oops, sorry, wrote down the wrong. Cotangent of theta is less than 0. So cotangent is the reciprocal of tangent. And so that's basically cotangent is x over y, right? So if it's negative, then we either have one negative and one positive. Okay, so you want to consider a negative x over a positive y, and we want to consider a positive x over a negative y. So we're looking at our negative x and a positive y, that's quadrant 2. And then a positive x and a negative y, that's quadrant 4. So we see both of these have quadrant 2. So quadrant 2 meets both conditions. So the answer for part B is quadrant 2.